Brennan Ashby. This is John Skirka and Mike Casper. We're working on a Planner, which is a LAN party management system. Yeah, so I wanted to just kind of outline the basics at a glance kind of thing so you can read that for yourself. But basically, we are writing it in Python. It's a client-server model. We're sticking just to Python. We're not really importing too many libraries, so we're going to be cross-platform. The basic idea is that you can, well, okay, so the idea started is I'm the president of the gaming club, RGA, and we do LAN parties, and we had trouble with multiple tournaments and people signing up for multiple tournaments and then having conflicts. So we decided to write some software to help manage the LAN party, make it easier on us, kind of automate the whole thing. So as it says, you can schedule multiple tournaments. Part of the automation is to alert the users when it's time to play a certain game or do a certain thing, and then hopefully by the users coming back and reporting who won, unless there's a disagreement, the system can then like collapse on itself and progress to the next game. So we don't have to stand over them, that kind of thing. Because before we were doing like Excel spreadsheets, that kind of thing. It was very hacky. It didn't work too well. So this is a lot of words. Obviously, we don't need to read them all, but I just kind of took the major features and broke down kind of what they each are. So like we're using for our user password system for security, we're looking into SSL, but we're doing a kind of salt hash thing where you talk to the server. Well, actually, he knows all about that. He's going to talk about that. So, but that's what we're doing. LAN party scheduling, run multiple events, handle time conflicts, as I said. Tournament scheduling with a given LAN party. That's part of the automation, keeping track of each user, because like each user can create an account into the system, so when they log in, it can tell them, hey, you signed up for this tournament, you've got this game waiting, you should play this guy. The bracket generator is just like a visualization. You put in the amount of players, and the rule set is it double elimination, is it round robin, you know, how many players per team, that kind of thing, and then it'll build out the bracket, and then that way it's all like visual.
Ash, you will give me a talk next week.
Yeah, I mean that's basically it. Display information, future lines, you know, alert people about events that are going on. We're using PyGTK for our visualization library. That's a quick screenshot of the login. I want to demo it later, but I'm going to let John talk about the authentication as I was talking about.
Alright, so one of the major problems that we first ran into was how to send a password and authenticate a user without anyone being able to sniff network traffic and get the password. So we originally looked into SSL, and we found that to be not really exactly what we needed. SSL uses a third-party server to basically authenticate your server and make sure you're connecting to the actual server, and we really didn't find that necessary. So what we do is the client will log in using your password, click connect, and then the server will generate a random hash key and salt to send to the client. So the salt and the key are sent to the client. The salt is added to the password and then hashed, and then the random key is added to that and rehashed. And then we send that to the server to look up in the database. So that makes it pretty much impossible for someone sniffing network traffic data to gain access to someone's password. And now for the network models, we considered 3 networking models to build the client and the server. Synchronous, threaded, and asynchronous. So the first one, synchronous, is the idea that everything is iterative. That's like when you first learned a program, it was a synchronous program. One task happens after the other end. Task 2 has to wait until task 1 completes before it can do anything. If you think of the tasks as different clients trying to connect to the server, you can kind of get an idea of what's going on. Basically, this model is really horrible. You don't want to use it at all because user 2 will have to wait for user 1 to finish whatever he's doing in order to do any input output, which is really terrible. So the next one, the threaded model, is probably what most of you are familiar with. It's basically all the tasks that are happening concurrently. So task 1 and task 2, user 1 and user 2 can do input-output to the server really independently of each other, and that's really great because everything's happening concurrently, and there's no slowdown. But also, this is kind of bad because it adds a lot of unnecessary complexity to the program. The operating system really controls when threads start and stop and when you have to wait for one thread to complete, which is makes the program really complex and a lot of headaches. You know, program threading is very difficult to do, even for someone who's very good at programming. So the third model, asynchronous, is kind of the same idea as threading. Like you can split the time that the processor uses between users. So tasks are interleaved with one another, but they're still in a single threaded control. And this is a lot simpler than the threaded case because the programmer always knows that when one task is executing, there's not another task executing at the same time. So why asynchronous? Yeah. Go back. Sorry. Well, there was text on the next slide. I don't know what happened to it. But basically, the reason we chose asynchronous is it performs very well under a couple of circumstances. One being where you have a real lot of tasks for the server to calculate. So if you have like a real lot of users waiting for input and output from the server, one task can be waiting while the CPU is using another task and working with that other task, and that's really how a web server works. There's like a lot of users trying to do stuff at the same time, but input and output is really kind of slow compared to processing power. Another thing that really makes asynchronous work well is when you have a lot of tasks, but you don't really have to share data between the tasks. So if 3 users are logged in, user 1 doesn't really have to communicate with user 2. So that really eliminates the idea of why you would use a thread to communicate data between the threads. Since we don't need to do that, asynchronous is really the way to go for this program. So that brings us to Twisted, which is a really cool networking library for Python. Next slide. And what Twisted is, it's a module that makes it easy to implement custom networking applications for both server and clients. So Twisted already takes care of all of the concurrency with multiple clients connected to the server. So you really don't have to deal with all of the lower level programming when you have like 100 clients connecting to a single server. It'll take care of all of that for us, which will make it a lot easier to program. Another really awesome thing while we're using Twisted is it supports a lot of like networking protocols that we're going to find really useful, mainly SMTP. What we want Planner to do is the ability to alert people as to when they're having a scheduled game for a tournament. So let's say like I have a game Friday at 8 p.m. Like I can set it so that Planner will alert me via email or text when my games are, so I don't forget. And that's already really built in to Twisted, so it'll make coding that a lot easier. And Twisted is also asynchronous, which is another plus.
Okay, so yeah, something all wanted planners need is a tournament graphic generator. So there's a few different ways to have tournaments. You could have single elimination, double elimination, and round robin. Those are the 3 that we want to implement. So it's pretty single elimination. Single elimination is the easiest to do a bracket for. If you lose one match, you're out of the competition, you continue. And if you have a power of 2 players, it's the easiest because then nobody gets buys. So like but then you need either like 64 players or something would be like 2 to 6, and then like 128. But then if you have somewhere in between there, the number of players that get buys is like the the top out of 2 minus the number of players, and then that number of players get buys. So next on with the tournament is a double elimination. I like this a little bit better because if you lose once, you're not out of the competition. And something that happens in a single elimination game is like the first place team may face the second place team, and then the second place team gets eliminated and is out of the game. So like that's not as exciting, I guess. So double elimination helps like more good fighters get to the end of the game. Yeah, I thought that line was kind of trippy, so I put that in. But because what happens is there's 2 brackets. There's a winner's bracket and a loser's bracket. All the losers from the first game play each other. And then all the losers from the winners, from the next round of the winners, play the losers. And then they continue on. So go on to the next. Round robin is the last kind of bracket that we need to implement. This is the last one we'll implement because it's like not as common. Like double elimination. See, something that happens with double elimination is there's way more matches than single elimination. Round robin, there's going to be a lot of matches too. So, like that's why a lot of even though single elimination has downfalls, we'll probably play a lot of single elimination games. But it's still something we should implement. Having a land.
I think that's it. Any questions? Yep.
So back on the user authentication slide, you said you didn't use SSL particularly?
Right.
What I can see basically is that it still allows like a man-in-the-middle attack, because you basically, man-in-the-middle will just take the server's response, pass it to the client will pass it through, and then man-in-the-middle can now nefariously pass in messages acting as the user, because there's no encryption or verification of the data being sent. And sure, the person in the middle won't know the password, but from the server's perspective, they've been authenticated as the client.
Well, that's assuming how would they gain access to the connection? So when someone logs in, it sets up a TCP connection, and that's what you use to send the password over and authenticate.
Yeah.
And then once that's authenticated, it'll gain access to all of the user's information. So how would the man in the middle get into setting up another TCP connection?
The man in the middle works based
There's
on
Wireshark on the back of this computer.
Yeah.
Just use you just use Wireshark as
He'd be sniffing packets, right? He could see, I guess, when you have a tournament set up, but there's nothing really that he can gain from seeing what time you have your tournaments or what tournaments you're signed up for. There's nothing really that we need to encrypt that would be of any use.
So Brendan mentioned that you rely on the users, right, to say who won.
Right.
So let's say I show up to an RPI LAM, an RGA meeting, and I'm malicious, and I want to rig all the matches or something like that. I'm taking bets or whatever, and so I set up and I intercept all communication when people try to report who won, and I lie. You know what I mean? So I'm the man in the middle. I receive the request from someone over TCP, and I say, well, actually, this guy won, and then I let the message continue through. I'm Joe, and I reported that person A.
Whoa!
and I lie about who won, then I can rig what planner thinks.
Yeah.
What planner thinks happened.
You
right?
could, but the way it would work is both users have to agree on the outcome of the tournament.
Yeah, so you can just
So I lie
whole
And if you're
set.
very good, you could get into both of them and report for each user playing the tournament the results. But we're also going to have an admin who can also dispute the results. So if that does happen and a user brings it up, we can go back and change it.
And then I was wondering why, so you guys went with Twisted as your networking library, and then you talked a lot about security because you don't want passwords to get sniffed and stuff like that, right?
Right.
You want to make sure people are safe. Why did you guys opt to do Twisted and then your own encryption for authentication instead of using Django or another, or Cherry Pie? I think one might be a little lower down, but something that does the server stuff on your behalf.
Well, the Django, you mean for a web server?
Yeah.
So we're looking into that. hopefully in the future, like once we have the basic desktop client and server model set up, we're gonna look into like implementing maybe a Django web server so you can access that. But right now we're gonna just focus on the desktop client and server, and then maybe add that in later if we have time.
How are passwords encrypted in the database?
So they're stored, the password plus the salt, and they're hashed with then they're hashed in the database.
What hash?
So
What
not
hashing
in
function?
Okay.
What hash function?
I forget. Do you know
Not so.
Just because you didn't mention how they were stored.
right.
As long as it's not MD5.
Yeah, it's stored the password plus the salt and then hash.
Yeah, use decrypt.
Yeah,
Good.
decrypt.
Yep.
So, for transferring data, why don't you make like a nice NSA approved algorithm for the key exchange while you're logging in, and use that to transfer that later, you just encrypt it.
We could do that, but the reason is because we didn't really see a need to encrypt the data that we're sending, because I mean it's just like tournament times and what time and what tournament the user is in. So encrypting all that data we kind of saw unnecessary, which is like the main reason why we didn't look into it.
Are there any other applications that do what this does? Like it seems like this would be a fairly popular like application, just because it's like a scheduler, and I'm sure like what would your application do then that another LAN scheduling application doesn't do? Because it sounds like this is all pretty straightforward, like scheduling stuff.
We did look at what other things have been set up. There was one that is now defunct, so that isn't really working anymore. You can go there, but it doesn't really work. There's a website called Challenge that only makes brackets, which is pretty cool. But
Well, I
doesn't
mean,
really...
like, I bought, like an example, like a chess tournament or something. You have two players that have to play each other. There's tons of software out there that will set up and administrate a chess tournament. So then all I'm guessing then the difference would be is you're no longer.
So what our program is it's basically like an all-in-one program. So it'll do the tournament bracket generating, and it'll also have like alert messages as to like when your tournaments are, and you can basically set up your profile to like see what kind of tournaments you want to enter. Basically, it's for the gaming association, so they can add different custom tournaments and set up like different LAN parties to their specifications.
So is there going to be like an administrator dashboard?
Yeah, we're gonna add support for like an admin saying like they can log into the server and customize all of their tournaments and LAN parties and time and stuff.
I mean, the difference between your chess example is mostly that the idea is that we'd be running multiple tournaments. So the idea is that like it would tell you like if there was you should play this tournament versus just a basic here's a bracket.
Right. There's gonna also be like multiple games and tournaments going on.
I mean, you
at the
can
same
be in
time.
more than one at a time.
So users will be able to sign up to whatever tournament they want to be in, and it'll show like conflicts between like times. Let's say you want to be in this tournament and in this tournament. Well, the program will tell you, hey, there is a game like at this time, so if you want to be in both of these tournaments, like that might not work because both games would be scheduled at the same time. So it's like there are programs that do some of the features that we have, but there's no program that does all of them.
So I've so you guys mentioned that you do notifications, right? So it'd be cool. Do you do SMS notifications?
Like with Twilio, is that?
No. So it'd be really cool if I could get like a text
Like a text
message,
message?
because I think
Yeah.
you can send emails through text messages, right? That's a
Yeah,
thing.
we're gonna look into
That's
that
a-
probably through like maybe Google or something.
Because that'd be so cool, right?
No,
If I'm playing a game and I get like a text message in my pocket that I need to go play someone. And I think this actually solves a pretty non-trivial problem, especially with scheduling. And I think what could be, now I don't know how the RGA game tournaments work. I don't know if people sign up beforehand before they come and play.
Yeah. That's,
Okay, so what would be really cool is if like you had everyone sign up and they had to sign up before the tournament started, and then Planner knew who was playing in what games and could schedule games to avoid scheduling conflicts as much as possible. So like it knows, well, if we start this game at 6:30, then everyone will be able to play, and everyone who wants to play in this one will also be able to play in the one afterwards. and like it can optimize. I don't know. It sounds really.
I mean,
sounds
you'd have
kinda-
to like kind of hopefully guess how long each game's gonna run, since some games.
Right, yeah.
One of the problems is kind of predicting like how long.
But you
each
could
tournament
definitely
is gonna run.
try and do that.
And it's kind of hard to say like, okay, this tournament's gonna be like an hour long.
Okay.
You know? So I mean, that's the idea though. That's what we're trying to like accomplish. But it's gonna be a little difficult.
I think it sounds exciting, and it's great that you especially have the president of someone who would use the software.
This might be kind of hard, but have you guys considered being able to refer to, say, the server in the game that's being played, so maybe you could go observe it, or do like a feed?
Oh, the actual.
Maybe provide
Yeah.
like the IP for the server's running or the,
That was-
the
Yeah.
source TV. Like,
And then
I don't
again,
know.
the problem is a lot more.
But not like running right in the program. We didn't really do
That would be cool. Yeah, that's not really like the scope of Planner, but we could like add that.
You could have links that link to it, but
Yeah.
not running in it probably wouldn't be really that necessary.
More things.
Yeah. I would like to have